One part.
Is the blindfold showing, or could you able to change the color or something?
No, it was just like it was a clear picture, but the clear picture turned blurry.
I
Blur
could do the blindfold.
for that patch, right? Whatever we were trying, or you got blur overall.
Yeah.
Oh man, okay. See, the idea is basically having a specific part of the image kind of change, not the whole thing. So that's what we will try. And it's not that difficult. Means I don't know why. Okay, we have certain image libraries as well. So it's very easy in image library. It's just a function. You start with so many centimeters or so many inches from the top and just the bottom. So you can do it that way. But that's the kind of easiest way. I want you to understand how that rasterization or how that overall pixel imprinting works overall. So that's why I had given you that idea. Give it a try or something, or we might find a source code and we'll try to play around with it, because I haven't worked on that, so I need to search for that source code and then show it to you. But yeah, it's not that difficult. Give it a try, because this is the way you're going to learn, and we're going to even also research as well. Go to GitHub, try to find out masking in an image kind of projects available there, and then we can get those things applied, or masking a part of image. I think that's what the technique we are looking for. Okay, and we haven't used the image library. There are some image library within Python, but we haven't used that. They are available. Okay, but yeah, I want to understand the overall array. I want to understand the overall data frame conversion of the whole image, and then converting it back or putting it back together. And that's the thing which if you want to start working in something like face recognition type of stuff, or humanoids, or something like that sort, so it'll be helpful for you. Okay, so let's do one thing. Try it on your own, or in the next session I might grab a source code and we'll basically do it together. So important part here, we are trying to mask a part of the image and put the image back together as an image. Means whatever JPEG, GIF, whatever format that image is in, right? It's not that difficult, but I can understand, because we know busy schedules and all those things, you might not have or like ma'am say, got working, and then certain errors are coming or something like that. So these things do happen, and things get updated left and right, even within Python environment as also. So if you keep the updation off, means be it something like Anaconda, or be it something like Python version updates internally. If you just switched off the Anaconda version update, it's more than enough, because Anaconda keeps checking whenever you start Anaconda, it goes and checks for each and every version of libraries, the Python compiler, the interpreter, and all those things. So that thing we need to keep in mind. Because once you start working, and if the version gets changed, then also you might get errors sometimes. It do happen. Okay, yes. So we started with pandas versus anybody have any other question for me as of this moment?
No, I'm good.
Okay, no problem. Plus, please do try, because unless until you tried it, you might not be able to get it sorted out. And try to what you can say, address the challenge by yourself, so it will really help you out in the long run. Okay, sure. Let's say pandas versus numpy. So we had a good look at the difference as well. We had seen the overall video as well. The array objects in numpy is ND array, and there we use data frames. It provides a lot of supporting function that makes working with ND array very easy. So data frames are the most efficient data support mechanism. ND array is specifically for the numeric crunching. So whatever you do with number crunching across the matrix, across the 2D array, ND array could be used effectively. Arrays are mainly used in data science, and where the speed and resources are very important. Data retrieval versus data crunching, or we trying to basically match up the overall efficiency with ND array for data throughput. So the retrieval should be fast. Even the data crunching in terms of conversion, addition, subtraction, multiplication, and all those manipulation on numbers. That's why normal called number crunching. That should also help us with ND arrays, and that's why we use NumPy as well. The source code of NumPy is available freely. There's a specific directory of NumPy on GitHub, so you can look at that as well. In case you want to have a look at certain specific commands that is available, but NumPy can help you through Anaconda, so you don't have to go to the source code for that. But if you want to explore more, you can do that with GitHub NumPy subdirectory as well. Let's understand. Okay, these things keep changing. So I think this was 3 months ago. This thing worked. So I don't know if it works today. So we need to check out these things, and they might change. Just github.com/numpy. That's all. Means it do keep changing. I don't know why it does happen. It does happen a couple of times for me as well. So we understood the NumPy versus pandas. These two basically lets us make the data science, a kind of the most efficient throughput mechanism. That's what I will say, including numerics, including data frame object or ND array objects. So uh, have a look at it, play around with it. I believe you must have tried certain things. So I'll not repeat many things again. In random numbers in NumPy, sorry. Okay, as we discussed last time, as a data science, whatever we create is in a specific range of numbers generated. Even random numbers, they are generated in a specific range, and that's why we use something called pseudo random here. What is pseudo random? Well, it's a randomization, but within certain gamut of range. So if I want to generate a random number, I'll basically try to regulate that number as well. If I told you to think a number, and you might restrict your thought process to between 1 to 20, and that's what we do normally psychologically. Whatever number we first think, it's in between 1 to 20, unless you are, something kind of high IQ or something like that. But yeah, that's a normally the thing. Similarly, thought process in NumPy. So whenever you generate random numbers, they are pseudo random numbers. So I can basically generate between 0 to 1. If I'm trying to develop a matrix, or if I'm trying to develop an empty array with so many rows and so many columns, we'll get a specific random number number of random numbers generated within a range of 0 to 1, and that's the by default property of pseudo random generation in NumPy, where we use this specifically whenever we try to basically plot a graph with random number. We try to understand certain distribution series with random number, and there we use this pseudo random numbers, and we'll see in a couple of these things. I might have showed you this example, right? To generate 3 and 5 basically means 3 rows and 3 rows and 5 columns, and that's how the matrix get generated. Have you seen this, or do you want me to show it again? It's a simple 3-line program to generate pseudo random. Okay, so here we've just trying to use the rand function into a random library within NumPy, and that's what we are doing. Let me showcase this program to you, and we might play around with the number of arrays, column, and have a look at it, how these things changes. Okay, let me get started on Anaconda. Let me. So this is a random number Python. Okay. What? Oh, yeah, starting out with it. It's taking a longer time. Starting. Let me go to Spider directly. Forget about the anaconda thing. So yeah, in Spider we have to just cut and paste this, 3 lines of code, and that way with Spider. So I'm launching the Spider. Okay, let me share that thing with you. So that click on Spider. Okay, I can share the Spider. Pardon me for that. Spider. See if I open that random number file. Yes. Yeah, this is a simple 3-line program, 2 rows by 3 columns. And if I run it, could you see my screen?
Yeah.
Yes.
Okay, so 2 by 3, and I can change it as much as I like. So I can say 6 by 3, so it'll give me that many rows, those many columns, and so 2. And depending upon our need, we normally get these things generated. Okay, there are methods to normally it's from 0 to 1, and this is how that distribution thing works. Let's try to understand why they've clamped it at 0 to 1, and then we'll go into details of how we change it and how we get basically getting this thing. Now, probability density function. We've understood this PDF when we were learning mathematics and statistics. A random distribution set of random numbers that follow certain probability density function. So we are looking at a kind of scenario where the numbers are within a specified range. So we are trying to understand a distribution within a gamut of density, within the gamut of the density function, right? A function that describes continuous probability. So it's a kind of evolving probability till it evolves to a certain extent, or number of iterations are limited within the evolution. The PDF or the probability density function is used to specify the probability of a random variable falling within a particular range of values. So this is a kind of direct implementation of those pseudo random numbers within Python using NumPy. Okay, falling within a particular range of value as opposed to taking any one value, because when you say random function, and if you use in C, R, or even R has a limited random function now, but in Python, this is really based usage of PDF, or limiting the random number generation to a particular range of values. The probability given by integral of this variable PDFs over the range is given an area under the density function, but above the horizontal axis. So when you talk about distribution, the more range you apply, the more your graph will be higher, right? So if you try to have this PDF plotted, Python distribution plotted, or any of such graphs you want to plot, the best way is between 0 to 1. But you can use the greater values as well. So the probability distribution is a non-negative everywhere. Normally it's a non-negative, and its integral over entire space is equal to 1. So max 1, whatever you're looking for, right? So let me try to play these values, and then we apply some additional some additional methods to plot the graph as well. So we were at okay, PDF Python. So let me open that file for you. PDF. Okay, it's open already here. So I tried it yesterday. So here, what I'm trying to do, I'm trying to give a random choice. Now I'm using something called random choice. Okay, and here we have 2 matrices. I already hard coded them. One, complete numbers. Second, between 0 to 0.4, and I have also given a size to that. Okay, so try to play around with the random functions within NumPy, and you'll get an idea. Here, when I try to run it, the X has these values. So like 12, 12, 9, 12, 7, 7, 7, 9, 12, 12, 12, 2. Okay, so here, it's a size of 12. And if I increase the size to, let's say, 21 and play it again, the size is increased. So I'm trying to control the overall distributions within the specific values. How many specific values I want, I'm looking at. I can go take to a bigger number as well, and so on and so forth. So here I'm trying to restrict the PDF, the probability density function, within so much of a values. The total distribution is from 12 to 2. So this is the lowest number and that's the maximum number I have. If I do it like here, if I put something like 21 or 211, and let's try to play around with it again. So here the values are between 7 to 211. And that way we can play around with it in terms of how it differs, how it basically how it's changed the value in terms of overall plotting the whole number distributions across it. And it's does change. It means if you rerun the program, the distribution does change, right? It not changed as of what we're thinking. If you can see here, 12 12 9 2 2 1 1, here we have 9 9 9 and then 12 12 12. So the PDF does change at all. Means you want to plot a graph, the graph will be a bit different. Okay, and that's what the fun of it. And we'll see where we're going to get this thing used. So please try to play around with it. I think I already shared this PDF with you. If not, I'll share it again. Do you have these PDF with you? Probability density function?
No.
No.
No, okay, I'll share after the session. Don't worry on that part, please. Pardon me. Okay, so here shuffling array. You can have that ND array shuffled in terms of reshuffle again rather than running the program again. So this is like playing dice. If you want to make a game for playing dice, you can use this simple program. It's just a program of 3 lines, right? About 5 lines at total, 2 inputs and 3 actual programming lines. And here what we are doing, we are trying to do a randomizations with the shifting array. Okay, so this is like you are trying to have dice of 6 values, right? And I have given 4. So yeah, that's also another 5. So that's also another limitation here. But yes, you can have a game of dice playing. So whenever you say they shuffle, it'll get shuffled again. Or you can reshuffle the whole old number and get it used to. Okay, it's simple, copy paste. Try to play it around in your Spider or whatever editor you're comfortable with. Okay, it's a simple program. I'll share this with you. Okay, let's move. Let's try to understand how these distribution functions help us out in finding the solutions what we are looking for. Okay, and one of the foremost we use is Poisson distribution. This is pronounced as a Poisson, Poisson, and various other. I normally don't go there. I normally try to pronounce it as a Poisson, and this is what we pronounce in South Asia. So please pardon me for the pronunciation. You need to understand the pronunciation you use in your region, even during Midwest or eastern part of North America. I find it pronounced differently. So please don't hold me for that. Try to use the pronunciation as you like. Even whatever interviewer says, that's a correct pronunciation. And that's the way we learn. So in corporate America, you have to basically get aligned with whatever pronunciation you worked with, and that'll basically give an edge over others as well. So we try to get mixed up with the whole pronunciation things quite a few times. So don't worry on that part, and nobody will quote you out how could you pronounce it differently. Okay, so don't worry on that part. So Poisson distribution, the probability theory and statistic, the Poisson distribution is a discrete probability distribution. Discrete probability distribution. So we are trying to address probability distributions within a span. Discrete in the sense, well, it's a secret, it's a unknown, but still we are trying to limit the probability to a given span, and that's the most important in terms of trying to control the distribution or trying to control the outcome of a mathematical output within the programming gamut. Okay, that expresses the probability of a given number of events occurring in a fixed interval of time or space. Now, where we are using this thing, we are using to understand the distribution within a fixed interval of time or a space. What do you mean by interval of time? I try to, what I can say, limit the clock span between 3 p.m. to 5 p.m. I'm just, throwing a raw number here. Space between, the length of 100 meters to 110 meters or something like that. So what I'm trying to do here, we are trying to limit the Poisson distributions within the gambit of programming space here. So we are trying to be more accurate. We are trying to be more and more refined as we go on in terms of plotting this Poisson distribution, or trying to understand how Poisson distribution can help you within a given set of problems, or within the given set of solutions you're trying to generate. Okay, yeah. If these events occur with a known constants mean rate and independently of the time since the last event. So even what we are trying to do, we are trying to control one variable in the randomization only. That's a normal demand. Could you control more? Yes, you could control more. You can have two numbers generated independently and keep shuffling them as well. Like you can have two dice play, like dice, right? A six-faced cube which we normally throw and try to get a number out of it between 1 to 6. Similarly, you can have two independently, Poisson distribution numbers as well, if you're trying to try something like that within your data scientist solution. Okay, the Poisson distribution can also be used a number of events in other specified interval types, such as distance, area, volume. We just discussed that thing. Now they're trying to explain it to you in depth in terms of understanding how this Poisson distribution helps us to build solution. For instance, a call center receives average call of 180 calls per hour. Possible? Yeah, very much possible. The 24 hours a day. Within 24 hours, we are receiving 180 calls. Pardon me. For instance, a call center receives average 180 calls per hour. This is the average. It can be study of last 3 days, last 30 days, last year or so. 24 hours a day, the call center runs 24/7. That's what they want to mention here. The calls are independent. Receiving one doesn't change the probability of when the next one will arrive. So whenever we try to understand the time gap between two calls, they haven't synced, because normally whenever the calls are received, there is some peak time, there is some lag time, right? In a normal scenario, wherever you are, whichever time zone you are supporting, normally mornings and evenings are heavier in call centers, because you get major number of support calls during those times. This is a normal for any support like credit card, banking, this product, that product, and so on and so forth. So that's a generic one. There could be some product where you get the calls during afternoon or during late night or something like that. So specifically, if you look at support center of a cable television or this satellite dish television, you normally get the support calls maximum number within 9 p.m. to 12 p.m. and that's the probability we are talking about. Okay, so here we are trying to consider call center where we get 180 calls per hour and it works 24/7. The calls are independent. Receiving one does not change the probability of when the next one will arrive. The number of calls received during any minute has a Poisson distribution, Poisson probability distribution. The most likely numbers are 2 and 3, but 1 and 4 also likely. And there is a small probability of being as low as 0, and a very small probability it could be 10. So we are looking for a kind of Bell distribution. That's what or Matlab distribution. These two scientists have plotted a curve for Poisson distributions, and it's really a thumb rule where we normally have the peak in between, right? So we have a peak as we discussed, a normal call center have a 2 peaks, a morning and evening. But if you look at something like cable TV support or satellite dish TV support, you have a peak in the evening. And for that matters, you can have these if you calculate the deviation from a peak to the non-peak, the graph normally looks like a bell. So it's called bell curve, or Maslow's distribution of theory, and something like that sort. So these two theory we normally use in appraisals across the globe. So that's why I normally can recall them. So that's a kind of curve level we use. Wherever you work, you might basically denote this theory by some different scientific name as well, because quite a few scientific thought process have evolved with such theories. Okay, let me play you a small video where we'll try to understand how data science statistics help us to plot these Poisson distributions for us. Give me a minute, and I'll have I yes, I have. So I'll close the scene. Yes. So I'm looking at wait a minute, let me share that video for you. So that's all about Python distributions. And as I told you, the overall pronunciation does differ as per the region you're working in, right? So let's move on and try to understand how we're going to use or how we're going to plot the Python distributions within our solution cabinet, right? So let's just rephrase. The Python distribution is a distribution which shows the likely number of times that an event will occur within the predetermined period of time. So here, the time window is what constant, or time window is what we are trying to limit for a given examples, right? I'll share a couple of videos with you additionally to understand Python distribution in detail. This was a short and sweet video. There are some good videos like 30 minutes or so, and where the Python distribution is explained in depth. Okay, it used to be used for independent events which occur at a constant rate within a given interval of time. So if you think of something like a customer returning to your shop, so it's a kind of independent event which occurred at a constant rate within a given interval of time. So when you say constant rate, a customer visiting you number of times in a day. So how many customers can I get for a particular thing, particular interval of time? So this is like between 9 to 9, the time your shop kept open and all. So these kind of distributions or these kind of problems we normally get solved with Python distribution. The Python distribution is a discrete function, meaning that the event can only be measured as occurring or not as occurring, meaning the variable can only be measured in a whole numbers. Okay, we try to plot within the graph within the whole numbers. We use Seaborn. Seaborn is a Python library which has inbuilt functions to create such probability distribution graphs. Also, SciPy package helps us creating the binomial distribution. So here we'll use even Seaborn package. We'll discuss about Seaborn in a couple of slides. But this Seaborn is a library which is famous for plotting graphs, 2D graphs, 3D graphs, pie chart, and all those things are normally easily plottable within Seaborn. They have specified functions and you just pass the numbers to the thing, and the Seaborn library can get a graph plotted for you in the graphics terminal. Okay, why I've said this specifically in a graphics terminal? Because the way Linux Unix treated output as a text and a binary. So whenever you try to print certain image, the image gets rasterized in a image, sorry, not, it's a graphic terminal. And the numbers are in a normal terminal. It's called TTYY terminal. Text to text, I don't remember what that Y is for. So it's just text terminal and an image terminal. So here the graphic means the image terminal, right? Also SciPy package helps us creating a binomial distribution. So we might be using SciPy package for the distributions of the graphical points. So let's try to understand here. This is a program. It's a simple program. 1, 2, 3. It's like 5 page, 6 lines programs where we'll plot a Python graph. Okay. So let's try to understand. We are importing Python. We are importing Python from SciPy. SciPy statistics have a library called Python. So we are using a importing a typical part of a library, and then we are using Seaborn. So these two library together will going to plot this graph for us. We are using something called RVS within Python distributions, where I'm passing certain set of numbers. So there's a mu. Mu is in that Greek letter mu, which is normally marked for the distribution within the Python probability functions. Then the size is overall the size where I'm trying to address the number of repetitions, number of event occurrings, and then I'm trying to build a plot, trying to build the image called AX with the Seaborn's displot method, with passing on these different numeric different variables, so that it will plot a graph for me, and then I'm trying to set the graph on the pattern on the graphical output terminal. So it's simple program. Don't go too much into the different variables available here. KD means there's a specific way of plotting a graph. Color is basically you can use green, red, yellow, whatnot. Try to play around with the colors, what you can do. And then we have a line width in terms of how much the graphs, as this, we are using some particular graph. It's called vertical bar chart with some, linear graph as well. So it's a combination of two graphs we are trying to use. And you can have these, line width to be mentioned at a 25 pixels. And then we have alpha. You can try with different, numerical values as well. And, plot the graph in output terminal. Let me play this video for you so we'll understand in depth. I'll open my this things. Let me check out the file. I forget this thing. It's Python distribution most probably. So I'll open the file. It's not Python distribution. Okay, let me try to paste that file. I'll copy from there. I have a new file and I'm just pasting it over here and I'm running this thing. It takes a while first time. See, could you see the Python graph? And I can change it to, I believe, red, if that's available. Let me try to. So yes, there are a number of colors available, and this is what I am talking about, the graphical terminal. So these are the plots, what they say. Normally our outputs is shown here, but normally the graphical term. Could you see my spider, right?
Yeah.
Could you see the graph?
Yeah.
Yeah. So it's a simple graph, and I can change a number of variables here. Try to play around with it. And if I increase the width of the these things, let's call it how much, 60. I'll try to play again. So the width increases, you can play around with these things and try to find out how we can have this pattern distribution plotted for us within just a 5-line program. And 2 of them are reports. Normally it's a 3-line program what we're talking about. To plot this, even in Excel, you need to click at least 8 to 10 times. Well, Excel is a ready-made software, right? It's a product by itself. So is that easy in Python if you know the functions to use, if you know the variables to use, and there are many such code snippets available on the net as well. If you go to W3 schools, I have taken this sample from W3 school. So you can use this sample and you can play around with it. There are a number of samples available on W3 school as well. So you can have a look at that and try to analyze how we could use this Python distributions plotted across our graphical terminal, right? And then we have something like Matlab building. What we are trying to do here, we are trying to build a scatter graph. This is called scatter graph. So scatter graph gives you overall distribution. This is another way to depict the distribution. Okay, and so you can have these dots plotted on a x and y axis thing, and then you can try to understand where is the maximum density. Like the density is between 2 to 3, right? This is the most dense, and in between 0 to 100, or rather I'll say around 50. So this is the most dense part of the overall event occurring, right? So this way we could use these different type of libraries to have these graphs plotted for us, or try to understand visually how the distribution is looking in terms of the given events occurring, the weightages and all those things as well. Of course, these are 2D graphs, there could be 3D graphs as well. So don't worry on that part. You need to just understand first how we use it, why we use it, and then you can go on plotting various colors using different type of graphs, charts to plot this or to showcase within your group, so that we will understand or get even various suggestions from other scientists as well. And that's how we use these different graph plotting techniques whenever we work as a data scientist normally. Okay, does that make sense, or am I confusing you?
I'm good.
Anybody use Python distribution before?
I got it.
Never?
No.
Okay, no problem, no problem. Okay, so but you understand like why we use Python distribution?
Yeah, I understand.
Right. So just to repeat that, if you're looking for something like a range of customer coming to your shop within so and so time, so you can understand how long I should keep my shop open, and we can decide something like that as well. And I'm just talking about the most lame example here. We use this graphical probability function and Python chart at a much complicated levels. Like even if you look at if you remember the Netflix example we discussed earlier, so I might plot a Python distribution for number of religious sitcom watched in within the Midwest region and what time they are watched. Okay, so that I can understand the peak show timings. I can plan or readjust the overall show distributions within that region as well. And that's how Netflix really using these models or data scientist models to achieve the better business divide. They have, of course, quite a few number of such intelligent program working for them around the clock, and their program keeps suggesting these doing better can be sitcom distribution, movie distribution, advertisement distributions for a specified given time or within the specified given time and all. Okay, let's try to understand Seaborn and why we use Seaborn. So we understood NumPy, we understood what's the other one? Pandas. Okay, now let's try to understand the third one. Okay, NumPy and Pandas are the most used. Seaborn is used wherever you want to have plot graphs, pie charts plotted on the graphical terminals. Okay, Seaborn is often used because it makes attractive visualization and works easily with the Pandas and NumPy. Yeah, so this is a kind of evolve library. Let's have a look at it. How? While the matplotlib, you often have to write multiple lines of code to create a plot. Seaborn makes assumptions on what you want, which often translate into getting the same plot with one line of code or couple of lines of code. So in Seaborn, it assumes quite a few range and other variables, like we tried to plot that Poisson distribution, right? Then we have built-in themes, like we say, the green, the bar chart with the line chart combination, and so on. Okay, have a look at these themes available on a GitHub. It's mboscom /Seaborn. Okay, so have a look at these things, and you'll get a quite good number of matplotlib graphics available there. We can get these details at even seaborn.pydata.org, and there's a tutorial available there also. So have a look at that tutorial, and you'll understand how we could leverage from Seaborn. Let me play your first tutorial on Seaborn so that you'll understand in depth how this Seaborn helps us day in, day out. Okay. In terms of trying to plot a graph from a mathematical data set, from a Excel sheet, or from sorry. Okay, no problem, but yeah, it happened. So feature of Seaborn, basically, let's try to understand Seaborn in depth, right? Now we've seen how Seaborn helps us in terms of plotting graph, like all those different type of graphs, charts, and everything. Let's try to understand Seaborn in depth. Seaborn built on top of Python's core visualization library called Matplotlib. It means to serve as a complement, as an addition, as an extension, and not a replacement. However, Seaborn comes with a very important features, and let's see the features. Let's try to understand them one by one. This is a really important from interview perspectives as well. Okay, so please review this, have a look at this again. I'm going to share a couple of other examples as well, which you can go through, because these are lengthy in nature. They'll go line by line. Even there are 4-5 lines of code. You have to understand each of them, right? To plot a graph, to plot a chart, scatter graph, join plot, and all those things. Okay, so here built-in themes for styling Matplotlib graphics. As he explained how KD is implemented, right? The graphical element of it. How coloring is simple. You don't have to in Matplotlib, really go color by color, pixel by pixel, and paint it separately. In Seaborn, you just have a grouping color assignments, and that's what makes it really important to change the color, like we change in our example, right? The color of bar from green to red, and then we increase the overall shape and size of those vertical bars we plotted in our example. So that's why it's really easy visualizing unvariable and bivariate data, univariate and bivariate data. We've seen this as well. Univariate, you just have one constant, one variable plotted on a graph. Then you have bivariate. You have two variables plotted or two PDFs plotted on a single time regression model. Fitting and visualizing linear regression model. So all these regression models have to be, as we discussed, we can even restrict the randomized function if you want to plot a graph. So you can really zero down to the event horizon from start to end and align your graphs accordingly with the pseudo random functions available in Python. Plotting statistical time series data. This is a normal thing, right? You can do it in Excel, you can do it in C, you can do it everywhere almost. Well, but the code required in Python is hardly few lines. That's why the Seaborn really helps you out. Seaborn works well with NumPy and pandas. It's tuned up with NumPys and pandas for Python platform, and that's why the whole process makes it really in tuned, efficient to get these things plotted for display for visualization. It comes with built-in themes for styling. I think I'm repeating that. No problem. So okay, we can use all those styling things from Matplotlib in Seaborn. So it's just an extension rather than reinventing the wheel. So if you have a program or solution already developed in Matplotlib, it's really easy to migrate to Seaborn, because you're just going to rename couple of methods, couple of extensions, and that's it. And then you can use it with Seaborn with much more ease, much more efficiency. In most cases, you will still use Matplotlib for simple plotting. So if I'm not using heavy plotting themes or process, I'll go with Matplotlib because it's easier, which I'm doing it for quite some time now. But if you're starting new, I will suggest start with Seaborn rather than Matplotlib. It's lengthier, it's older way. Seaborn is a new way of plotting graphs, chart, pie chart, and everything. The knowledge of Matplotlib is recommended to tweak Seaborn's default plot. So if you know Matplotlib, it does help. If you don't, it doesn't matter. Don't try to stress yourself to learn Matplotlib as well. That's why I haven't included Matplotlib in our session, because Seaborn solve the purpose for us. Okay. Does anybody have do anybody have any questions at this moment for me?
No.
We are good, right? We're understanding what I'm trying to say. Okay, let's move on to the next one. Now here we are trying to plot some waveform type of graph here. So this is what they call wide clip graph. I don't know why, but they call it wide clip graph, and it's a symbol. Plots I have plotted around 4 graphs with different line, and this can be with different range as well. Okay. I don't have a discussion for this. Okay. Okay. So it's a simple thing. Let me play this program for you. Yeah. Why I'm saying play, because I'm just copying and paste it in Spider, so that we can have these things. You can try it on. You can try to change certain variables and things here. Could you see this graph here in the video port?
Yeah, yes. Yeah.
So it's really simple. It's a sine wave graph where I'm trying to have 4 sine waves plotted across different these things. Okay, I'm still using line space as an 3 line space here. Then I'm using plot graph. I'm using Seaborn to plot this graph for me. So it's a sine plot I'm using, and there are various other sine plots in Seaborn as well. So if I go to if I want to go to a level where I want to check out how many plots are available in Seaborn, right? So Seaborn PLOTS, as simple as that. And you can have all those Seaborn plots available. And there's a GitHub also. So it's a GitHub from Jake DB, Jake VDB. That's what is it coming or not? It's taking longer. Sometimes these guys give you a lots of challenge in terms of loading GitHub as well. And there's as I told you, cpon.pydata.org, right? So let's try to visit this thing. See, so many graphs, types of graphs available as far as the Seaborn library goes, right? And you can go to each of these things. We have seen these line plot. We have seen joint plot. No, we haven't seen, but you can see. And there's a code available also, sample code. Could you see these things? You can just cut, copy, paste these programs, and it will run for you. So let me, try this thing for you, and you'll understand how to basically try different type of plots for you. Okay. So I'm just trying to show the way of plotting these different graphs. Could you see the plot there? And it's just 4 lines of code, or rather, it's just 2 lines of code, penguins, and then these things. So see how how easy to plot such difficult graphs. If you try to plot this graph, it can be something like 80, 90 lines of code. Okay, so play around with this. Try to visit this good website. called cbon.pydata.org, and you'll get all different type of graphs available within cbon. And please upload your code to GitHub so that whenever you want to try to use any of the graph, you can use this code already keyed in. So you just have to import the data, or club the data with the example you are trying to develop. So life is really easy nowadays. Okay, and this way you can get your half the code pre-cooked from the GitHub, and even every other scientist in the world know that, and that's why they give you access for all such websites, or you can request for these things. Okay, so have a look at these things. I don't know why that Getty was taking too long time, but yes, there are lots and lots of sample code available on GitHub, and you can try it on there. Try it on your own. Similarly, there's another another graph. Here I'm using typical matplotlib. And then I use cbon also. Yeah, so it's a color palette. I'm trying to use some color palettes. So this is used to select a specific type of colors, and you can use this color palette in your program as well. The program is there. Please have a look at it, and you'll understand these things. Okay. Next, we're going to start on SciPy. Let me stop here today. Okay, and play around with these 4 libraries we have seen till date. We have seen pandas, then we have seen numpys, then we have seen cbon, and what else? Oh man, I keep forgetting this thing. Cbon, and before that, numpy.
Matplotlib.
Yes, Matplot. Matplotlib we haven't seen much, but yes, no, we haven't seen Matplotlib. Do you want to have a look at Matplotlib? It's simple thing. It's not that difficult. But yes, let me add a couple of program for Matplotlib as well. Because normally we don't use Matplotlib nowadays. The cbon does helps a lot, and the rest of all the functions which were there in Matplotlib, mostly including in Python internal functions. So we don't normally use Matplotlib that extensively, but at certain exceptional scenario, like you're trying some mathematical or statistical project, you might use Matplotlib. Let me try to add a couple of slides of Matplotlib as well, so that in case if there's a question, you can answer those as well. But now I haven't seen any major questions on Matplotlib as well, so that's why I kept it out of the loop. But I'll include it. Don't worry about that. If you want to, add any specific libraries, do tell me. We do have TensorFlow, SciPy, PyTorch, and some major use libraries, so that at least you'll know around 10-12 libraries before you start your interviews, or if you started, well and good, no problem. But at least you can tell them like, I know all these libraries, and that'll be more than enough for them. You normally select a function within such a group of libraries, believe me, whenever you start working, so that you have to know more about those libraries rather than have a generic idea. And here we are trying to understand generic idea or generic major functionality used for a given library. Okay, so that's why this session course is more of a generic nature, and even Python data science as an overall gamut of solutioning, it's still generic in nature. Whenever you start working on actual problem, then and there will start learning more in depth of a particular library. So don't worry on that part as well. Does anybody have any questions for me at this moment?
No.
Keras and TensorFlow, they're also different libraries, right?
Yeah, there are too many libraries, ma'am. See, we are scientists, right? So for each and every problem, there could be some specific library, or we can use these generic libraries. There are permutation and combination we use generally. So whenever we get a problem, we might need to find out a library which fits nearer to that problem, and try to use that even from our experience as well, or the experience of our colleagues. So it depends, the group you work with, what are the library they feel are more important, more, their need. And that's why we normally learn the library which we are going to use, but we should know at least thing or two for all these 10-12 libraries. So if you want to work on a particular library, do let me know, and I'll include that library in our sessions. for discussion. And as we all discussed, right? These are just the thought sharing sessions.
Yeah.
Whenever you speak, there will be something called support. So if you get any problem, we might deep dive into let's say pandas, deep dive into Seaborn if there's a need arises. So don't worry. This is not a ribbon cutting ceremony. I've given you training now. Let's go by data. No, I'm going to help you on interview. I'm going to help you on the on-job support as well. Okay, so don't feel like I'm going to leave you as soon as this session finishes. No, nothing like that. Does that make sense to you?
Sure.
Yeah.
So let's
Yeah.
stop here. Thanks a lot for your time. If you have any questions, you can WhatsApp me. I'm going to share this PDF as well as those videos which we have shared together, and let's try to learn. Please try to do some hands-on, learning, because that's the need of the hour, and that's how you're going to learn more and more methods, more and more, understanding of these libraries. Because otherwise, I keep, speaking. I keep, discussing these things, and we might keep, forgetting all the older things which we've learned. Please don't do that. I know it's a big gamut of, thoughts, big gamut of learning as far as data scientist things goes. So please spend some time and do some hands-on practice. You have the environments with you, so you can do it. It's not that difficult. Okay, chalo. Thanks a lot for your timing. Any questions you do, let me know by WhatsApp or any way you think, right? And let's meet day after tomorrow, 9 p.m. again. Okay.
Thank you.
Thank you. Thanks a lot. Have a good night.
Thank you.
Bye. Take care.